This is the Sharp X68000, the Japanese god computer, the Amiga Killer. Let's see if it lives up to the hype right now in episode 81 of Retro Bits. In the last episode, I won this rare machine on Yahoo Auctions Japan using a proxy bidding service. I unboxed and inspected the machine, and everything appears to be in excellent condition, but I've yet to crack it open or power it up. I've been waiting over a month for this, so let's jump right in.
New Life Sharp.
今、黄金のマスクがよみがえる。パーソナルワークステーション X68000。
I don't know about you, but the first thing I do when I get a new machine is pop the hood and see what makes it tick. So before I hook it up to everything, let's do just that. And that's a good reason to have this handle here. It makes the machine easy to manipulate. I don't know how portable it would be considering there's normally a big CRT attached, but that's a nice thing to have for moving it around the desk anyway. We already took a look at all the ports on the back in part 1, so we won't do that today, but I wanted to draw your attention to the fact that all of the RGB video stuff is here, so I'm guessing the GPU will be in this tower, and the CPU and the main PCB will be in this tower here. There's also this lower section which houses the interconnect between the left and right side towers, as well as provides the ports on the front and the rear of the machine, so we're going to find a third PCB down here. Now, as far as the aesthetics of the machine are concerned, it does have a very interesting and unique design, but because of this split tower and the requirement to have at least 3 separate interconnected PCBs, this machine is a lot harder to service and to disassemble than your average beige box. So there is a trade-off between having all this style and having this machine be easy to work on. Now, I couldn't find any disassembly instructions for the machine in English, so I'm not sure if we need to remove these I/O slot blanking plates or not. I'm not going to initially unless I find that I have to later, so I'm going to start with the obvious screws first. So this whole panel should now slide to the back, but I've read on the internet there are some plastic tabs that we've got to release in order to do that. So I'm going to push in here while I slide the panel back. And there we go. Yep, there's tabs here, here, and there. Oh yeah, and you want to be real careful when you do that. You can see that there's plastic catches along the top and also along the bottom. And if you're not careful, this plastic could be brittle and you could break those. You don't want to damage your X68000. These parts are not replaceable. So we can't see very much. We have obviously a cage here for the expansion slots, and we also have another cage here for the RGB module, but the GPU itself is hiding behind this RF shield, and it takes up, there's a PCB that you can just see peeking out through some of these cracks that takes up the entirety of this tower. So the GPU board is going to be this entire PCB here from here to here, and then you can see the interconnect that connects the GPU board to the backing plate down here, the interconnect plate at the bottom. We've got a power connector, and we've got an aftermarket battery that was already installed by the refurbisher. Yeah, I'm a little disappointed that you can't see more of the GPU, but you'd have to remove the expansion slots, you'd have to remove the RGB module, you'd have to remove this little PCB here that controls the lights on the front panel, take off all this RF shielding. I'm really not sure it's worth trying to disassemble this thing just to get a peek of the board under there. I know it's been fully recapped, I know it's been serviced. I'm glad somebody else did it, to be perfectly frank, but I am disappointed that you can't see more of this machine. And that goes right back to the fact that these things are very difficult to work on and service because of their design. And here we are on the other side. Removal of the case was exactly the same as the first side. What we've got here is the power supply unit and power supply fan, the guts of which have been removed because now we have an external DC power supply that feeds directly into this aftermarket unit here. The original supply is no longer present. Here we've got a space for a hard drive. This is where the original hard drive would be provisioned if this was the HD model, which it is not. We have the 2 floppy drives installed here, and then we've got the floppy drive ribbon cable connecting to the back plane here. We've got power, and we've got the SCSI connector on the back plane here, which connects to the 50-pin Centronics connector on the back. But one thing to note is this is not a 50-pin SCSI connector. This is a proprietary ribbon cable that goes from the back plane. And if there was a hard drive installed, the ribbon cable would continue on to a 50-pin connector here. This is a proprietary connector. If you want to connect an internal hard drive, you need the proprietary connector. You can buy them for about $50 online, or you can make them yourself. But the wiring is a little complicated. It is documented in English though, so it can be done. It's a little difficult to see, but right behind the hard drive area, we have an internal speaker just peeking out right there. And one last thing to note is that there does not appear to be a large PCB in this tower. So I was wrong when I said earlier that the GPU was on one side and the CPU is on the other. It appears that they are both on this side and that one large PCB consolidates them both. Now, that may not have been true for earlier models of the X68000. It may be that in this model or some intermediate version that they consolidated the GPU and CPU onto a single PCB for cost savings. I have not read anything about that in any of my research, so if anybody knows the answer, do let me know in the comments, but it does appear that this side is just accessories and that there's no overarching CPU or PCB here. Now here's something I didn't notice when we looked at the box the first time in part 1, but a viewer clued me into this little disclaimer that appears only on one side of the box. Let's get a look at that. And it says that these products are strategic products subject to COCOM regulations. They should not be exported without authorization from the appropriate governmental authorities. So this machine was export controlled due to ostensibly its power or capabilities, which may be one reason that the X68000 never saw sales outside of Japan. Interesting. All right, it's well past time we got this thing hooked up and tried it out because I've been dying to get it connected since I've bought it more than a month ago. So the first challenge we have to deal with is the fact that it has a proprietary 15-pin RGB connector instead of a more traditional HD15 connector. So what I've done is I've bought an adapter cable from a company called Retro Cables, and I'll put a link in the description, and it just converts the X68000's 15-pin DB connector to a standard 15-pin HD connector. So we should be able to hook this up to any compatible VGA monitor. The second challenge is that the X68000 can output 15, 24, and 31 kilohertz RGB, and I don't have a suitable display that can handle all of those refresh rates. I was hoping that the Samsung LCD from 2 episodes ago would be fixed in time to hook it up to the X68K, but that is not the case, so we'll have to do something else instead. So what I've done is I've built this, and this is called the GBS-Control, and it's a project that allows you to take a $20 commodity upscaler, the GBS-8200 upscaler, pair it with an ESP8266 Wi-Fi microcontroller running new firmware that acts as the new brain for the upscaler chip, and you get a Wi-Fi connected high-powered RGB upscaler for less than $30. And I just 3D printed this case and I stuck all the parts in there. There's a little soldering involved, and I've also integrated a CGA to RGB into the design as well. So this will work with EGA, CGA, and Commodore 128 RGB graphics as well. So analog and digital RGB to VGA for about $30. And I hope this works with the X68000. The last consideration is the power input. It's already been converted to a DC input, so the original 100-volt supply is gone. And along with the machine, I was sent this power brick. This is a 100 to 240 volt, 50 or 60 hertz input, and it puts out 12 volts at 5 amps. So that's what we need to use with the X68000 now, is a 12 volt DC power supply. All right, I've got the X68000 all connected up. The RGB output goes to the upscaler, which goes to this Dell flat panel. Everything else is connected and power is hooked up. We've got a standby light there. I'm gonna turn it on for the first time now. No YouTube trickery. This is the first time I've ever pressed the power button. I fully expect it to work, but you never know with shipping these old machines halfway around the world. So fingers crossed, here goes nothing. That's a good sign. The light turned green. We've got fan. Do we have video? The drive 0 light is flashing. Maybe I have the wrong input. VGA. And it went to sleep. All right, I don't know what's going on. The monitor went back to sleep. So let me fiddle and I will be right back with you. All right, status update. I think the problem may be with the upscaler. I've got the UI for the GBS control on my phone here. And if I select a resolution, the monitor comes on. We see the missing disk boot screen, but it's out of sync. So I think something is wrong with the upscaler here. I don't think it's a problem with the X68000 itself. So stay tuned, more fiddling. Okay, we're making progress here, and I think I know what the problem is. I've got the VGA monitor directly connected to the X now, and as you can see, the image is stable. It's waiting for a disk. The problem, I think, is it boots into 31 kilohertz mode by default, and I don't think the upscaler knows what to do when it sees a 31 kilohertz signal. It's trying to upscale a signal that doesn't need to be upscaled, and I think that's the problem. So, with it directly connected to the monitor, I think we're in business to try and boot something. All right, so here's the disk that came in that little pouch. It appears to be a copy of the operating system, so I'm going to throw this in and see if the machine boots. The one problem is, I don't know which way the disk goes in the drive. Does it go this way or does it go this way? I'm going to take a guess and put it in this way. We'll see what happens. Well, there is an error on the screen. Let me translate that error and see what it means. Okay, so I translated the error, and what it means basically is this is not a boot disk. This is not a system disk. It can't be booted. It didn't detect the human.sys file on the disk. So whatever this is, it's not a backup of the operating system. All right, I'm back again. This time I have the original Human 68K disk that came with the system. We'll throw this in and see what happens. Oh, that's promising. There we go. I think we've got to a command prompt. I also think the command prompt is below the screen. Yep, it is below the screen. All right, that's interesting. We need to adjust the display a bit. But good, we have a booting system. It seems to be working. The drive works and the system boots up. Now let's test out the floppy eject. What's kind of neat is that it shows a green light when the drive is inserted but not active, and it shows a green light here on the eject button when there's a disk installed. So press eject and boop, the disk comes right out. I'm gonna have to make a copy of this right away so I don't use the original. And one more thing I wanted to demonstrate is the soft power switch here. Apparently, when these machines first came to market, this was a novel concept and it hadn't been seen before. But what happens is if you press the power button, the machine goes into a sort of soft sleep mode and it powers itself down. But because you never actually shut off power to the PSU is always on unless you flip the big toggle switch in the back. That seems to be one of the reasons that the power supplies are notorious for failing nowadays, because they were never shut off. They were on for the entire life cycle of the machine in this standby mode where they were energized, but the system was off. So that may play a role in why the power supplies are so prone to failure these days. And what happens if we turn it back on, I wonder? I can't imagine that it resumes. There's no hard drive, there's no non-volatile memory. Yeah, it's back to the boot state. So no resume, just soft power off. Let's talk a little bit more about the video output from the X68000. It uses some very unusual display modes, 512 by 512 at 55 Hertz, 256 by 256, resolutions that LCD screens just weren't designed to handle and can't really display properly. We've already seen it because we know that the command prompt is way off the bottom of the screen somewhere. And if we go into the screen settings here and we go to display settings, and then we go to display reset. Watch carefully. There's the prompt. Below that, there's even a status bar, and it tries for a moment to sync up to it and to display the entire screen, but it just can't. And if we go here to the vertical position and we move it up to its maximum adjusted range, we still can't even see the prompt, much less the status bar that's below it. So LCD screens just aren't a good fit for the resolutions that this thing is putting out. I've also mentioned that the X68000 can use 15, 24, and 31 kHz video modes, so I'm going to boot into the game that the system came with, and we're going to see what happens with this LCD display. And there we go. The display simply can't handle the resolution that the game is putting out, and that's going to be the problem with a lot of modern LCD screens, or even normal VGA monitors. They just can't sync down to the 15 kilohertz that's needed by this game. So I've tried every single display I own, and none of them will work properly with the X68000. So I'm kind of in a pickle here where I can't show you anything because I don't have a proper display to do it. So what about the GBS control? Can this upscale the game's 240p output for an LCD display? Unfortunately, no. I tried it and it just didn't work. I had to enable the debug console, and I found a message saying unrecognized source format. So GBS control just is not compatible with the X68000's video output, and a quick Google search confirmed that as well. So there's a buying tip. If you want one of these systems of your own, you're going to need the matching Sharp CRT monitor or one of the rare VGA CRTs that can sync all the way down to 15 kilohertz. Otherwise, you're going to need a more expensive upscaler to be able to use the system with an LCD display. This is one variant of the open source scan converter, or OSSC. And what it is a high-powered upscaler that is known to work with the X68000. This particular unit was loaned to me by my good friend Jason Sullivan at Pinay Collectibles. So thank you, Jason, for bailing me out when I had no other option to get the system working. Now these devices are not exactly cheap, at around $200, but then again, nothing is when it comes to these systems. So let's get this hooked up and see if we can actually start using the computer now. And through the magic of YouTube, there we go. We've got the full screen, we've got the command prompt and the status bar, and everything is nice and centered in the screen. Now, this is a pretty advanced device, so you're going to have to read the manual because there are a lot of settings that you're going to have to go through to get things just the way you want. But it can be done, and the results speak for themselves. Yeah, so it's no surprise the LCD panel had a hard time syncing to this signal. I mean, 568p at 55.40 Hz, just X68000 things. Now let's see how the scaler handles the game that we tried earlier. And just like that, it works. I didn't have to change any of the settings. Awesome. And that's nice, we've got a little animation and some background music playing. I've seen that with other X68000 games as well. So that's a nice little premium feature that you would expect given the price of the system and the price of the software too. And this game is running at 260p with 61.44 Hz vertical and 15.97 kHz horizontal. Now it's funny, it spits out the disc once the game's done loading. Before I forget, I want to make a copy of the original system disk onto this blank floppy that came with the system, so let me do that now. The first thing we need to do is to format the second disk, which is easy. just like DOS. Right, and now that that's done, we can use the copy all command to copy everything from A colon to B colon. And just like that, we'll create a full duplicate of the original system disk onto this blank. You know, I really like the dual disk drives in this machine with the 2 LEDs and the 2 eject buttons. They really have a premium feel to them, but you would expect that on a machine that costs this much. Now, in terms of cost though, there's another machine which is lurking right there in the background, the Macintosh Classic 2, which, adjusted for inflation, was really in the same ballpark as the X68000 in 1991 when both of these machines were on the market. So if you think about it in terms of what you got for the money, the Macintosh is a black and white machine that doesn't have any of the fancy graphics or sound that the X68000 does, but they really cost almost the same. So if you put it in that perspective, this seems like a pretty good deal. All right, there we go. The copy's done, so we can eject our original. We won't be needing to use that anymore. And we can put the copy into drive 0 and hit the reset button. And there we go. It's booting. We have a good copy. In terms of software that came with the system, we have the Human 68K, which we just made a copy of. We've got the SX Window GUI, which we will take a look at in a little bit. And then over here we have the Japanese language word processor and the dictionary for the word processor. So let's take a look at this one for a minute. And there we go. We have our graphical word processor and it's mouse driven. I can't really understand what any of the menu icons are, but we do have a full user interface here. And one neat thing about this is that the keyboard lit up. As soon as the word processor loaded up, the lights came on the keyboard showing the different character sets that we're in. So if we hit the different buttons here, you can see that the screen updates to show what character set we're currently using, which is kind of neat. Yeah, so I clearly have no idea what I'm doing, but it's kind of fun. You can change between the different character sets. And remember that full width half width key, there's the L character with the key turned on. If I turn it off, there's the L character with the key turned off. So we have one that's a full width character, and then we've got a half width version of the same. Now, if I turn off all of the special characters, then I can just type in Roman characters with the caps lock key. So that works as expected. But yeah, all these other keys, I really don't know what I'm doing with this word processor. Now, all these different character modes seem awfully complicated to me. As I understand it, one reason there were so many Japanese-specific systems in the early days of home computing was because the Western systems just didn't have support for all the Japanese characters that was required or the way to input them. So think about the Commodore 64. It just didn't have all of these capabilities in its single character ROM set. So the Japanese had their own systems until PCs became more ubiquitous and supported that sort of stuff. Now, floppies are all well and good, but the system has a built-in SCSI controller, so we should take advantage. And for that, we have a lot of options. The first, of course, is spinning Rust, but this is 2023, so we're not going to do that. Another option is a Japanese product called the Bansho, which is designed specifically for these old machines and supports SCSI and SASI. But it's about $100 plus shipping, and I think we can do better. A third option is the RA-SCSI or Pi-SCSI project, which was originally designed for the X68000 and also provides networking to the host machine. So that might be something we can look at in a future episode. There are also the SCSI 2SD devices, which are known to work with the X68000, but also cost around $100. And finally, we have the newcomer to the scene called the BlueSCSI, which is quite affordable at $50 or less. I purchased this external V1 model from Joe's Computer Museum, and while it works fine on my Macintosh, I couldn't get it to work reliably on the X. Joe kindly sent me the latest V2 model to test out, and I'm happy to report that it works perfectly.
What's really nice about BlueSCSI is that it uses disk image files instead of native partitions like the SCSI 2 SD does. That means you can easily go back and forth between your emulator and the real hardware. Speaking of which, here's the XM6 emulator, which we can use to create the drive images for our BlueSCSI. In the Tools menu, select Image, then make a new SCSI hard disk. Give it a name, then select a size up to 1 GB, which is the maximum supported on the X68000. Once that's complete, we can add a new SCSI device in the options, and point it to the image we just created. Finally, we'll mount a freely available Human 68K floppy disk image, reboot the emulator, then use the built-in format command to prepare the drive. After that, it's just a matter of using copy all like we did earlier on the real hardware. Now, we can format an SD card. FAT32 works, but exFAT is preferred. Next, copy one or more drive images to the card. BlueSCSI supports up to 7 files, each representing a separate device. Finally, we'll rename each of the images with the prefix HD and a number from 0 to 7 that represents the SCSI ID on the bus. Removable media such as CD-ROM drives are supported as well.
Ultimately, I want to install an internal drive, but I need the proprietary cable to do that. So for now, I'll use the external port with this Centronics to DB25 adapter cable. It'll get the job done for now, but it is a little bit clumsy. And just like that, we're booting off of the BlueSCSI V2 on the image we just created. Now, I don't have much software on here yet, but I did put patched versions of certain commands on here, such as format, which is now translated into English, which makes it very useful when you are navigating nested menus that have many complicated options in them. So that's a good thing to have on here. We can access all of our disk images using the different drive letters from the command prompt. But let's say we want to boot to a different operating system. To do that, we'd run the switch command, which is essentially like the BIOS on your PC. And all we have to do is go down to the boot device and change it from standard, which is first the floppy and then the first hard drive, to whichever hard drive device we want to boot to. So in this case, let's say we want to boot to SCSI 1. Now all we have to do is save the changes to non-volatile memory and reboot the system with Option, Control, and Delete. And just like that, we're booting into SX Window, the graphical environment operating system for the X68000. Now, we looked at this a bit in the Mr. episode, and I figured I would at least build the hard drive image and install the software as a remedial exercise, but I don't have anything really on here to look at right now, and it's quite difficult to utilize because everything is in Japanese here. I will say that the UI is pretty nice and works well, so it may be worth another look in the future. What I've got here is a SCSI hard drive image of action games that I've downloaded from the internet. And it's got this menuing system here, and it says the 90s sexy computing. Yeah, absolutely. So here under Games 1, we have all of the games that will run on an unexpanded system. And as you can see, there's quite a few of them. And I've tried them all. Here under Games 2, we have a bunch of games that need to be run outside of the menuing system, and I've tried all of these as well. And then finally, we've got Games 3 down here, which are all games that require 4 megabytes of RAM, which I can't play yet because this is only a 2 megabyte system. So once I upgrade it, I'll be able to play these last few games that are here under Games 3. I was testing out some games, so I hooked up the controller that came with the system, and this is the Arvel Joy card, and I noticed some text on here that I didn't see originally, and it says, "This Joy card will make you a better player and provide hours of fan. Good luck." Well, thanks Arvel, I'm looking forward to having hours of fan. However, This controller, while it works fine, is not really the most ergonomic. It's really not the best controller for playing games. So I'm going to set this aside. Instead, I'll be using this Mega Drive Genesis 6-button controller, which should provide a better gaming experience. Now, back in the original day of this system, Capcom and some others made an adapter that would let you use this controller on the system. More recently, you can buy a cable, and I got this from the same company that made the video cable, and so this will allow me to use all 6 buttons with games that support it, such as Street Fighter II and a few of the other fighting games. So that's what we're going to do.
The X68000 is often credited with having arcade-perfect ports. While this is true, a good number of them are titles from the 8-bit era. Remember that Street Fighter II hit the arcades in 1993, so games like Bubble Bobble here, first released in 1986, were really the system's contemporaries. While not an official part of the series, this homebrew version of Galaxian is a bullet hell homage to the original. Pretty cool remix, and only available on the X68000.
Round 1, fight!
There were certainly a handful of later, more advanced arcade titles on the system as well. When we looked at Street Fighter II running on the Mister's X68000 core, it suffered from a sound glitch that caused the PCM audio to stop playing after a few seconds. No such problem running the game on real hardware though. Capcom wasn't the only one to bring its high-end fighting games to the platform. There are a handful of others as well, but in reality, the number of truly impressive 16-bit era arcade titles is somewhat limited. It's not all that surprising due to the relatively small market the system existed in. Still, it's fun to think about what could have been had the Sharp been sold worldwide instead of only in Japan.
In the last episode, I mentioned that the mouse can be turned into a trackball for games that support it. However, I wasn't sure how to convert it exactly, so a number of you commented on it, and I think I know now how to do it. So the first thing is you have to flip it over, and when you do that, the ball falls towards the front of the mouse. Then you flip the switch to T from the M setting. that will keep the ball locked in place so when you flip it back over, the ball does not return to its lower position. Next, you have to turn this knob, and then you can remove this whole piece from the top, which will expose the trackball. However, mine seems to be kind of stuck in place, and no amount of gentle persuasion will get it to come off. So I'm going to resort to my favorite tool, the old plastic spudger, and we're going to give it a little bit of an assist here. If I can get it in and pry it up a little bit. Easier said than done. Oh, there we go. Ha, just like that. And there we go. Now we have a trackball that we can use for games that support it. So let's give that a try.
You may have noticed that we're only looking at action games. There are many Japanese visual novels and RPGs that I didn't try due to the language barrier. Among the 170 plus titles I did test, about half of them seem to be shooters, which unfortunately really aren't my thing. If they're yours, there are many excellent ones to choose from with great music, graphics, and unique gameplay mechanics. This game had severe graphical glitches on the Mr. Core, but it looks great on the real hardware. The level 4 space flamethrower is super OP though. Watch how fast it tears through the stage 2 boss. The X68000 is a 2D powerhouse, but 2.5 and 3D are not among its strengths. The system has no hardware sprite scaling, so it's not really well suited for Sega Superscaler titles. Whether because of the hardware limitations, the market, or the developers themselves, there simply weren't a lot of good racing titles for the system. When the X68000 first launched, I was still using a Commodore 8-bit with 64K of RAM and 16 fixed colors. Of course, I only paid $125 for my system brand new. Still, I can only imagine what it must have been like to have this experience at home in the late 80s.
Welcome to the fantasy zone. Get ready.
Initially, I was going to do some A/B comparisons between the X68K and the Amiga, but I realized that wouldn't be totally fair. Some of these titles were made by the original developers, whereas ports to other home systems were thrown together hastily by third parties on a shoestring budget. So instead, enjoy a few more titles I thought were interesting. By now you should have a pretty good idea of the graphics and sound capabilities of the machine, but let's briefly take a look at another music player for the system. This one was included with the disk image I downloaded, and contains tracks from many well-known game developers. Some are from the X68K itself, but many are renditions from arcades or even other home systems. Outrun was an unfinished work in progress that was never released on the system. At least we know it would have sounded amazing if it had been. .256 color VGA was introduced the same year the Sharp came to market, but the X68000 could display all 65,000 of its colors at the same time. And finally, full motion video.
It's going to be fun.
So, what can I say about the Sharp X68000 so far? Well, as you've just seen, it's a very impressive system with best-in-class graphics and sound that feels surprisingly modern and easy to use. There are, of course, a few caveats. First, the obvious, they're expensive to buy. You'll also need a special display or upscaler that can handle the unusual refresh rates and resolutions the system uses. Further, their rarity outside of Japan means that finding English language support can be a challenge. If you're thinking of upgrading your Sharp, be aware that certain accessories are highly sought after and can carry a hefty price tag as well. The same is true for the more popular software titles. A Commodore 64? This is not. It's not all bad news though. There's a very active X68000 community on Twitter. It's largely in Japanese, but thankfully we have Google Translate these days. There's also a large library of public domain and homebrew software that I have yet to explore. Much of it is archived on the NFG Games site shown here. Link is in the description.
So there we have it, a first look at the Sharp X68000. What do you think? Was this super home computer worth the high price tag? We've still got so much more to look at too. Hardware upgrades, video editing, other operating systems, emulators, heck, there's even a Python interpreter. All stuff for another time. I hope you enjoyed this bit. Thank you so much for watching, and we'll see you next time on Retro Bits.